So we'll get started in 1 minute.
Okay.
Okay, let's get it started. Hello, everyone. Welcome to the AI Talks series by MBZUAI University of AI. I am Lin Xiao. I'm currently the EVP and Provost of the university. So today's speaker is Dr. Kai-Fu Lee. Dr. Lee is the chairman and CEO of Sinovation Ventures, which is a leading venture capital firm focusing on developing the next generation of Chinese high-tech companies. Prior to founding Sinovation in 2009, Dr. Lee was the president of Google China and the senior executives at Microsoft, SGI, and Apple. Particularly, Dr. Lee founded Microsoft Research China, which was later renamed Microsoft Research Asia. So this research institute is considered the West Point of AI researchers and professionals, and trained the great majority of AI leaders in China, including CTOs or AI heads at Baidu, Tencent, Alibaba, Lenovo, Huawei, and higher. I personally have a lot of friends, former students, and collaborators who have worked at Microsoft Research Asia. Dr. Lee has been in artificial intelligence research, development, and investment for more than 30 years. His New York Times and Wall Street Journal best-selling book, AI Superpowers, discusses US-China co-leadership in the age of AI, as well as the greater societal impacts brought upon by the AI technology revolution. Today, Dr. Lee is going to talk about the rise of China as the AI superpower and how AI infusion will create tremendous value in the next decade. Without further ado, Dr. Lee, the floor is yours.
Thank you very much. It's my pleasure to have this chance to talk to friends and future students of this great university. And so I'm going to share my presentation. And what I'm going to talk about are China and the commercial uses of AI and some of the opportunities in going forward with, in particular, with AI applications, and also a little bit on what I think is exciting on research. So squeezing a lot of content. So first, I'm going to talk just about China. Only 10 or 15 years ago, many people thought China was a copycat. But today, everyone thinks China is a technology superpower. So what actually happened? This will show you from bottom to top, from 1985 to date, what the state is with the US leadership compared to China. Back in '85, when I was just in my PhD program, among these 6 rows, only the bottom one was in research, and US was dominant. In another 10 years, US still dominant. China had just a tiny little sliver. And another 10 years, again, still the same situation. But something really magical happened in the next 5 years. By 2010, China suddenly became had a place in terms of mobile and related to that payment and social. And in 5 or more years, China moved further in all of the areas. And most recently, I think China is now leading in some of these 6 areas. Still way behind in semiconductors, still behind in cloud computing, but pretty much caught up in many of the other aspects, especially mobile and AI. So how did this miracle happen? I think it's interesting to learn as a historical uh, just learning, but also I think it is interesting reference for countries and regions that also want to improve its technology status and even achieve superpower status. So how did China rise to become an AI superpower? Fundamentally, these are the 6 big reasons. Lots of AI engineers. Engineering is one of the top professions in China. And I know that UAE also would like to aspire to do that. China has some of the toughest entrepreneurs, which build great companies in which the engineers are employed to build great products. Thirdly, China really began to innovate, starting as a copycat, but eventually innovating. And that built the mobile ecosystem, 1, 2, 3. And then starting from 4, once you've got a mobile ecosystem with China's 1.4 billion people, data is all important. These mobile applications have so much data, and that data becomes usable to build better AI. As I'll get into later, having a lot of data is critically important, arguably as important, if not important, than having great AI researchers and engineers in the team. China also, with the success, brought in a lot of investments in AI funding, and the government policy is very supportive. To go into a little more detail on these 6 issues, I do acknowledge that North America by far leads the world in having the top AI scientists. These are the Turing Award recipients in AI, and they're basically all Americans or Canadians. And so that puts US at the very, very top of the pyramid. And I think that continues to be the case today. If you look at the next, let's say there are 5 more AI recipients of the Turing Award, they'll probably mostly still be North American. But if you look at the quality of publications in China, as we see here, the top 50% of all the papers, China actually eclipsed US last year. Top 10%, China will eclipse US this year. And in 3 more years, China will eclipse US on the top 1% of the papers. So while it's not at the 0.001%, which is what the Turing Award recipients are, it is at the top 1 to 10% already. So this is rapidly improving. And AI being the hottest area of study, on the bottom you see some pictures. At Sinovation Ventures, we hold a training camp for students, and there were 600 last year. And that's just one company. And there are many, many more. All the classes are completely filled, and AI is the hottest area to study. The second point is relevant because it's mobile, which accumulates data. China has created an incredible environment where entrepreneurs work incredibly hard in a winner-take-all game. So as an example, let's take food services as an example. In the US, there's DoorDash, DoorDash and OpenTable, Groupon, and Yelp, and other companies working in the food industry, each worth $1 to maybe $5 billion. But China has one giant called Meituan, and it is about 200 billion, and it started much later than many of the American companies. How did that come about? It came about because China is such a large market, so that companies that continue to gain market share, and the market expands and its share expands, it will have a higher market cap because it is consolidating and winning more market share. But equally importantly is Chinese entrepreneurs strong desire to play the winner-take-all game. I call that a gladiatorial behavior, almost like in the Colosseum in the old days in Rome, where basically only one gladiator will emerge victorious, and all the other ones will die. And that's really what happened. China actually had over 6,000 companies in the food business, but some were in Yelp-like businesses, some are in Groupon-like businesses. But in the end, they all fought each other and consolidated, merged, one beat another. Eventually, one giant one emerged. I think there are a lot of reasons for this, but certainly one is the incredible ambition and never being satisfied with even with success that caused Meituan to win this winner take all. And as a result, think about what happens from a customer user's perspective. We in China can order food. When I came home tonight, I had a choice of maybe 1,000 restaurants that would deliver to me in 30 minutes for about 70 cents. And that is the result of having a giant super app and a big network of 3 million delivery people who deliver, and also AI behind all of this. But the point I'm talking about here that's relevant to today's talk on AI is that these the paths of these 300 delivery people, the food that the 3 million delivery people, and the 10 million cooks behind all of the cooking, and the hundreds of millions of people who order takeout every week, all of that data is stored with Meituan. So it knows better than I do what I want to eat at any given night. And that is where the power of AI comes in. That's where the power of data comes in. So the key point I'm making here is the entrepreneurs who build the super apps that gain huge usage get the data from which they can do AI. That really is the #1 reason why China is ahead in AI. And Meituan is one example, but here are many other examples. I won't go into details here, but you can see that China used to be copycats, but then leapfrogs in some specific cases. Then it began to innovate. The best example being TikTok, a company that its parent company is worth well over $200 billion in just 6 years of founding. So the Chinese companies are in fact building suites of products and super apps on the basis of having huge population in China, then building AI to deliver great user experience and targeted experience, and then going abroad. So the Chinese entrepreneurs really are unstoppable. Now there are companies, foreign companies, now learning and copying from China. And China and US have developed into very different scenes in terms of what the consumer experience looks like. And for those of you who already work in AI, you know very well that more data is very powerful. And on the right-hand side here, you see that the lines are different algorithms. But the key point here is that when you have more data, you get better results. Your model precision, your accuracy improves. And certainly you can have a professor or a researcher who tries to improve from let's say this line to this line and get some improvement. But ultimately you can see that improvements in algorithm often is not as big as the improvement that comes from more data. And that's why, and so the model in China, the magic in China is more data leads to more AI, a better AI trained on more data. That's a good product that attracts more users and make more money. You buy more machines, hire more scientists, then your product gets even better and you get more data. So that virtuous cycle is what has got China to here. And in the era of AI, data is the new oil. So China is the new OPEC. And here are some examples. I won't go into details here about how much more data China has. And in a more modern example, beyond the mobile usage of takeouts and e-commerce, is an area that's interesting, especially during these COVID times. What about healthcare data? In the US, the population is much smaller than China. Hospitals are much smaller in capacity. And also the American rules and regulations are very tight on controlling, requiring the type of consent to even give anonymized data. So it's very hard to aggregate data. But in China, there are obviously privacy laws. You can't just take somebody's data without consent. But when you have anonymized data, aggregating them is a lot easier in China. So as an example, this is one company in China called Edu Cloud, and it has 1 billion medical records. So if you're believers like I am, that more data means more better AI, then it's very possible healthcare would be the next area in which China will leap ahead. There are a lot of money being invested in China. I think roughly about the same as US, and that's tremendous because US used to take the bulk of the investment from the world. Just at Sinovation, my VC, we have been one of the biggest investors in AI, and we've helped create 6 unicorns as investors when they were somewhere between 10 and $100 million, and now they're 1 to 10 billion. So we have done very well in AI, and China has done very well. The last point is that Chinese government takes a techno-utilitarian approach on AI and technologies. That is, letting these products launch first and regulate later. And also the Chinese government is really encouraging market economy, market-driven startups, but the government will take care of the infrastructure investments that are not feasible for private companies to do. As an example, in order to accelerate the autonomous vehicles, the Chinese government in different provinces and cities are paving new roads with sensors built in that make autonomous vehicles more safer. And even some cities are investigating downtown areas where the pedestrians and the cars are separated, thereby again making it safer. And that would allow autonomous vehicles to be launched potentially faster, even with inferior technology compared to the US. And as you know, once you launch, you collect data, you will improve. So that's something that the Chinese government's policies are very much suited to do. And this is what I talked about in terms of cities collecting data, sensors enhancing highways, and so on. So basically today, AI is very successful in China, probably going neck to neck with the US in terms of applications, commercial successes, valuation, market acceptance, training for engineers. US is still ahead in talent, but China is charging ahead in many of the applications and uses of technologies. So looking at the current state of AI, what are the challenges and successes and opportunities? I believe some of the key things to realize is that AI has gone through many phases, from symbolic to statistical to neural networks. Now that neural networks and deep learning have formed the nucleus and the foundation of AI research, I think there are two sets of really important things to look at. For research, I think what's important is to look at what's called system two. That is reasoning, planning, decision-making, going beyond classification and simple predictions, and going beyond simple neural networks, either using neural nets or a combination of neural nets and classical approaches to build more complex systems. I think that is something that's still unknown how it will be best done, and it's unknown how long it will take. So I would encourage people in universities really to view this as the next grand challenge. But those of us in the industry, we leave this to you, and we really focus on the bottom part, which is what are the problems that makes AI difficult to deploy? For example, can we get enough training data? Can we assure it's secure, protects the privacy, is robust with respect to bias, and is explainable? And these are some of the key things that need to be solved before AI can be deployed broadly. So the first point I made was in system one and system two. This book this slide is from Yoshua Bengio's talk, and it references system one and system two from Daniel Kahneman's book, Thinking Fast and Slow. Basically, his belief Professor Kahneman's belief is that there are two types of cognition. One type is fast, instinctive in recognition, perception. And these are things today's AI systems are pretty good at. But there's another kind of more deliberate cognition that is reasoning, analysis, and figuring out why and why not, and planning. So in terms of cognition, is basically about searching a large space and getting the best answer possible. But in system two cognition, somehow our intelligence allows us to focus and narrow down things and not have to exhaustively search all the things. So when we create something or make a plan, we're very deliberate and we know how to take the steps that solves the problem, and we don't have to really search everything. For example, if I um, want to know how to go from place A to place B, there's a lot of knowledge that I draw from about one-way streets and red lights and things like that. And I can plan a path in my head without exhaustively searching for all the possible paths. So these kind of planning and creativity are system two approaches. There are two ways to try to deliver system two. One is based on, let's put a lot of neural nets together, each one doing simple things, and then glue them together somehow. And the other way is, let's use neural nets for more perception and more simple tasks, and let's have some classical AI approaches connected to neural nets working in hybrid systems. It's not known which approach will work, and I think it's worthwhile for researchers to really try both. So let's move on. Moving on to some of the more recent excitement that we see in the research space. One area that I think probably has generated the most excitement in the last 2 years are in natural language. I think before that, probably the biggest deep learning breakthrough was convolutional neural networks, which enable computer vision to work much better. And pre-trained language models enable natural language to work much better. And there are many, many applications already. And it's exemplified in OpenAI's GPT-3 and also Google's Transformer and BERT. Basically, the idea is you take a huge amount of textual data, and then you train a general model without, without providing it precise supervision. All the pre-trained language model merely learns to predict words of the future. And that somehow, when you train it with the right structure and the right size of parameters, it manages to learn some of the concepts in language, and it learns to long distance relationships between words, so that it actually, when you use it in a generation mode, it actually can say things that really surprise us on how intelligent it is. I would encourage you to look this up. This is an exciting area of research. It's sometimes being compared with how humans take a number of years to build up our linguistic capabilities. Once we have that, we can tune it, use our linguistic capabilities to learn chemistry or learn music. And similarly, these large language models appear to be a very nice bootstrapping approach upon which you can build fine-tuned applications. In terms of computer vision, there continues to be good progress, including really, really advanced segmentation, object detection, and I think that is going to be quite useful in terms of applications like autonomous vehicles. AI can now not only do deep fakes, it can generate faces from scratch. So on the bottom here, you see a lot of faces that are automatically generated. And not only are these faces that didn't exist, and that each of the features looks very natural, we can't tell them apart from real people, but each one is somewhat self-consistent. If you imagine putting the hair color of the left person on the one next to it, it would probably look strange. So it somehow has learned how to put together features and in a way that looks coherent and harmonious. In robotics, there's also been a lot of research. I think robotics are improving significantly. The third example you see on the lower right is an arm that learns how to throw things into the right bins. Not with anyone teaching it with the precise motion, but it figures out based on trial and error, and very similar to a young child again. And in terms of games, the number one example is the Alpha Star, which goes well beyond uh, Go in terms of beating human players in the multiplayer game. And of course, probably the most important recent advancement, which I didn't have time to add a new slide in here, but I'm sure you've all read it in the news, is DeepMind's AlphaFold, the learning about how protein folding uh, predictions that are essentially correct almost all cases. And I think that can be a very strong basis for scientific research. So the uses of these AI algorithms really are spanning to more and more industries. So that's kind of the advanced AI research from what I saw in the last 2 years that are interesting. But as I mentioned, another type of research is applied research. That is when you are trying to take AI algorithms and building real applications in the real world, there are a number of limitations that may make it difficult. Here are 8 problems that need to be solved or improved in order for more and more applications to be built. Ultimately, what we want in AI applications is that any engineer, without knowing much about AI, can make AI work inside the application that the engineer is building. Kind of like how people can very quickly get up to speed becoming an Android or iOS engineer. So these are 8 of the problems that I think need to be looked at. I don't have time to go into a lot of details, but here are some examples. We know that the limitations of AI is that it requires a large amount of data. So there are techniques that are being experimented to see how we can use less data. And human labeling with supervision is very time intensive and resource intensive. So what are some research topics that will uh, uh, relieve that requirement? And it's difficult to solve cross-domain problems, and there are technologies that address that. Uh, the expensive computational resources can potentially be addressed by AutoML and other techniques, and that we need AI experts. Again, I think AutoML is a way that engineers can use this. So these 5 approaches, these 5 are problems of how to take AI from research into commercial applications. And these are some research areas that are intended for applied use. That is, when applied to these problems, a lot of their constraints become loosened. And there are also some areas that are not just constraints. 6, 7, 8 are examples of that. One is the privacy issue that a lot of people have. Basically the dilemma that if my personal data, if I give it to some company, then I fear that it would do bad things to me. I also fear that it might leak or be sold or be used by other people, not with the intent of what I gave the data to the company for. So how do you deal with that? One approach that's quite promising is called federated learning. And that means the learning, your data is only given to trusted entities that will use your data for training, improving models within the trusted entities. And beyond the trusted entities, your models may travel beyond that, but your data will not. So as an example, let's say my patient data in a particular hospital, they already have my data. So by definition, I've licensed my data to the hospital. So if they want to run a training algorithm inside the hospital, I should be okay with that. But if we have 1,000 hospitals, each with 1,000 patients, the way federated learning would work is each hospital would train models based on its 1,000 patients. Then the 1,000 sets of models from the 1,000 hospitals would then be aggregated together into a supermodel. So dividing the training into 1,000 pieces and gluing them together is one form of federated learning. And that solves the dilemma of needing to have all the data in order to train AI, but not wanting to give all the data to one person. So only give data to the entities you trust. Another form of that is what if in an extreme, is what if my phone is the only device I trust. So all the training should go on my phone. And then it can transmit my model parameters up to the applications, but never my personal data. So of course, this is non-trivial and there are a number of sub-optimalities that need to be solved. But that I think is a very promising approach, much more promising than the approach that European Union is taking, that is hoping someone would take all the data back and never, and one at a time license the data for its use. That's just really not very practical. Another area is ethical concerns and the bias and fairness. We've heard about examples where some company prefer not to hire women because its resume screening algorithms was not trained on enough women. And there are other examples like it. So I think the way to solve that really, first and foremost, is to make sure, for those of you who are incoming students, make sure you understand that you're not just learning to be an AI engineer to build apps, but rather you have a responsibility, not so different from the medical school students, that what you do can impact people's lives and health and even lives, and you need to take that very seriously. But training is one aspect. Awareness of responsibility, that's one aspect. But why can't we build better tools that detect imbalanced data, insufficient data? Just like our compilers would tell us when we have some dangerous constructs. I think our AI algorithms and trainers can do the same. And lastly, security challenges is a big area as well. And there are people working on ways to both detect deepfakes and protect from security problems. And also there are people investigating technologies like blockchain as a way to address problems like that. So these are the kinds of research that I think are interesting. And I hope that those of you doing research will think about these applied research as well as fundamental research. So these are some examples. I won't go into details here about how these issues are being addressed, just to make sure we can finish the talk and take questions from you. The last part I want to talk about is something I call AI infusion. I think the industry is, I think all industries are going to be embracing AI. And in my book, AI Superpowers, I talked about the waves of adoption. They will go from internet companies that have the most data. I think the adoption will begin with companies and entities that have the most data, and the data can be connected to business results. And then it would train based on large amounts of data to optimize business results in a single domain. For example, Facebook can try to optimize total user minutes. Amazon can try to optimize its revenue. And then it would target each individual user to show you something different that would help maximize that goal. And internet companies naturally have the largest amount of data, and the data can also be applied for business goals. So naturally, they have the most to gain, and which is why today the most powerful companies in AI are also the same as the internet companies: Google, Amazon, Facebook, Microsoft, Alibaba, Tencent. So it's no wonder. But then the second wave is coming soon, and these are businesses, especially financial companies like banks, investment companies, insurance companies. They're very similar to internet companies in the sense that they have a lot of data and they have business results that can be optimized. Let's say minimize fraudulent transactions. Let's say minimize default rates on loans. So those companies can run on that. And similarly, anybody who has data, whether it's governments, education, hospitals, logistics, supply chain, or back office. Back office is an interesting one because AI actually can replace human routine jobs easier than complex jobs. So back office jobs are among the largest numbers of our routine jobs. So a technology called RPA, robotic process automation, is being installed in people, let's say a group of people who do expense report approvals or basically enter expenses for the company. And RPA will watch the work of each individual worker and then uh, propose that, hey, did you want to do this next? And if the person says yes, they're essentially labeling data. And once it has enough labeled data to train, it will report back and tell the company CEO, hey, look, I've now understood your workload in terms of expense report department. I can automate 30% of the processes. So you can let go of 30% of the people. So that's going to be a predictable way where people, white collar routine workers, will be replaced by AI over time. The third wave is I call perception AI, and that is not just using existing data to train AI, but rather using computer vision, computer speech to recognize objects, to understand speech and machine translation, very much like our sight and sound, our ability to hear and see. But much more than that is that there are many other sensors in IoT that can sense other things. For example, sensing 3D with time of flight or structured light, and sensing movement, temperature, warmth, and humidity. So all of these things are things that humans cannot sense. So we can pretty much anticipate that AI will outsense us over the next decade. And the fourth wave is when AI begins to move and manipulate. So these are autonomous vehicles, robots, and the smart warehouses and smart agriculture. So these four waves clearly shows underneath each wave what industries will be disrupted. And when you add these industries up, they sum up to most of the industries in the world. So there's no doubt that over time, AI will disrupt them. On this slide, you see all kinds of companies that Sanovation has invested in. We've invested in over 50 AI companies, and they're being really applied to all kinds of uses in warehouses, in cars, in chips, in healthcare, in commerce, in banking, and the list goes on. So we anticipate as we extrapolate from all of these wonderful applications, AI will create unprecedented wealth. PwC estimates that a global AI market to be worth $15.7 trillion. And what's interesting to note is that most of these will go into not AI unicorns, but traditional businesses that embrace AI. And as I listed before, because these traditional businesses, the current AI penetration rate is only in the low single digits. So there's huge opportunity for upside. If you think about yourselves, your friends, your parents, how many of their companies are really using AI? Very, very small number. And so AI adoption is equivalent to internet in the yellow pages era, that is before the search engine was invented, or electricity before there was a power grid. So we're still in the very early stages of adoption. And as AI evolves, I think AI will go from about 7 or 8 years ago, something that's viewed as black magic, because only a very small number of people in the world know how to use AI, and they're going to start new companies. And because of their unique skill set, they'll get to try things, and if they don't work, they can pivot, try things differently. So that was the good days in the 7 or 8 years ago. But soon after that, AI engineers wanted to try to find products and solution sets for particular types of businesses. So that came the AI B2B space. Unfortunately, there aren't that many companies that need a standardized AI product, because AI is just not quite ready to become a SQL Server or Microsoft Office or one size fit all, because every company is a bit different. So we're now in a phase where I think we're more in what we call AI infusion. That means large companies are ready to use AI to save money or make money. And there's, generally speaking, not an AI product for each of these companies to use for each of the scenarios. So what the companies need to do is either to build their own team, or to find a consultancy, or to find someone like Sinovation which will invest in companies and help them infuse AI. And they will push themselves to be further ahead. Because as I said, the biggest opportunity now is for traditional businesses to embrace AI. And, um, uh, and in spaces where there are multiple competitors, the first one to embrace AI will have a strong competitive position. And eventually, AI will be so easy to use, all engineers in all companies can use AI, but that will still be at least 5 years away. For those of you who are old enough to remember the early days of the internet, it's quite similar. In the early days, there were companies like Netscape that were kind of the black magic internet companies. Then people tried internet B2B with companies like Commerce One and Ariba, which really didn't do that well. And then companies woke up and said, hey, wait a minute, internet's so important. Each company should embrace the internet. So I was at the time at Microsoft, and we said, we're going to start an internet division and figure out what are the lowest hanging fruits for Microsoft to use internet. And that was the early days of the internet. And 5 years later, every Microsoft product had the internet. So the internet division was dissolved. So AI is like the internet, except we're at a stage when traditional companies need to be and should be asking the question, how should I use AI? And those who adopt it early, uh, realize the gains, the upside early, will become the winners in the marketplace. So where would the traditional company apply AI? There are a couple of places. One is locally optimized, and there are two ways to locally optimize. One is pick something in your company. Don't disrupt everything in your company. Pick one single area and use AI to get you better bottom line numbers. So for example, if you're a loan company or an insurance company, you can source the customers, sell to them, and customer service, and everything can remain the same. The only thing that you change is if you're an insurance company, you will approve the insurance using AI instead of people. So that's a way to have a single place local optimization. Another way to do local optimization is to use it for cost savings. So let's say you said, you think, hey, my call centers cost too much. I want to use speech recognition instead of people, or I want 80% of the calls to be handled by speech recognition. So that would also be a local optimization. We talked about back office, the example of expense reports. So these would all be in local optimization. I think that's the easiest way for traditional companies to get started embracing AI. A more complicated example is what we call process intelligence. That is, you replace one local area at a time, and gradually your whole process becomes smarter. And the third way is think of ways you can embrace AI as a new startup that will completely change the industry. That's a little more difficult. Let's go into some details. So the first example is a local optimization. Here's an example where Sinovation helped a automotive loan company. Instead of having people who approve the loans, we had AI basically trained on about 1 million previous borrowers, labeled by whether they defaulted or returned the funds. So the classifier was trained to separate people who return money and people who default. And that was used for 1 month on real users, borrowers, to come in, and then it would decide which to approve, which not to approve. And the result was, just with 2 engineers in 7 weeks, we were able to reduce their default rate by 14%. And that leads to about $10 million in savings. So I think hopefully this illustrates the power of AI infusion, in this case, infused into a loan company. Let's move to something more complicated we call process intelligence. Here we help the company that has a grocery chain. We help them estimate how much of each product will be sold at each store in each city. And based on that estimate was trained on years and years of sales data, but also not only considering which store you're in, but also considering external conditions, like what's the weather? Is there a ball game? Is there a pandemic? Is there traffic? So these data would come in to feed the system to make a more accurate estimate about whether we would sell more diapers or beer or something else on any given day. So that system, when deployed, is then connected as the first application to do a intelligent replenishment module, which is we only have 3 diapers left. I believe tomorrow we'll sell 5, so we better order 10, and then we better put some in the warehouse in case we run out in the store. So it's an intelligent replenishment system, and this system resulted in significantly reduced inventory carrying costs and significantly reduced out of stock rate. So the revenue went up, and the shelf life became more appropriate. Produce didn't go bad, they didn't expire. So multiple benefits for the grocer. So they're very happy about it. And then in addition to that, they also started using it for just-in-time factory production. They started using it for smart logistics, figuring out how to transport from where, which distributors to use, and also intelligently decide where to put their new stores, because you can put the stores in places where you can optimize the entire system selling for revenue. And also, they also found it's very helpful for their process of expansion, because when the chain expands, one of the hardest things is hiring new store managers, because usually you need experienced store managers who've done this before in order to do replenishment decisions. But in this case, AI has now taken over replenishment as well as logistics. So it's much easier to hire store managers. They just need to be a pleasant and good people manager. So now the expansion can go faster. So now you see we're snowballing different parts of the retail chain so that it has lower inventory carrying costs, fresher merchandise, less expirations, and never run out of stock for any customers, and able to expand faster and has smarter, reduced logistic costs. So the cost savings becomes tens of millions of dollars. Hopefully that shows you how a company, in this case, a retail chain, can begin doing AI for one thing, but snowball it to improving the entire process over time. More of an industry disruption example is in healthcare. I'll use 2 examples. One is we invested in a company that is using AI to propose possible drug discoveries. It's a symbiotic tool sold to chemists. For example, the tool is sold to Merck, and Merck scientists would enter the possible drugs for it to work on, and the system would estimate the likelihood of success of the experiments, the likelihood of clinical trials, and then it would pick which drugs to work on that have a higher likelihood of finding efficacy. So early results show that it can speed up research by 5 times. So the future way in which the chemists and scientists work is different. Now they've got a tool. It's kind of like giving Word to reporters or Photoshop to photographers. It really changes the job category. Another area of a company that we invested in is looking at improved ways of doing neurological diagnostics. Some types of medical diagnostics are very difficult for humans to do. For example, diagnosing whether someone has Alzheimer's or Parkinson or some other problem is very difficult, because you have to segment the hippocampus, which is this colorful subject you see. And it's a 3D segmentation. So there's effectively no way for humans to do a perfect segmentation. And without a perfect segmentation, the diagnosis may be an error. And if it's an error, the medicine you use may not be helping the patient. And what makes it worse is for Alzheimer's and Parkinson's, there is no fatal outcome immediately. You are either worsening quickly or more quickly or less quickly. And there are many, many factors that causes people to worsen faster or slower, whether they're getting good care, whether they have good, whether they're working hard, whether they're doing exercises, whether they're taking medicine, too many factors. So I think it's possible when we have this much more accurate diagnosis of the patients, then it would have an accurate tracking of the efficacy of drugs, And that can potentially disrupt and change the way that neurological diseases are treated in the future. So in this talk, hopefully I've shown you that China is becoming a second epicenter of AI innovation. And that came about with large amount of data, and that AI can do a lot of good. We still need a lot more research, and we need to solve a lot more applied problems. And the exciting news is AI will create $16 trillion of value in the next 9 years. And I believe it will cause some problems, such as taking routine jobs away, but then it will also help to liberate us from routine work and help us to focus on what we're good at. And finally, I think the biggest opportunity for AI in terms of making money and commercial value is infusing AI to traditional businesses. And I think we're in a very early stage. There's a lot of upside to be had. So if you're in a traditional company, think about how to use AI. If you're an AI scientist, think about what's a traditional company you can help. That's the end of my talk. Thank you very much.
Thanks a lot for this wonderful talk. I think we have some time for questions.
Sure.
I've actually collected quite a few questions, both offline and online. I'd like to kick off by asking one question myself. So in recent 2 years, the media have been talking about the capital winter, and the VCs have become more cautious of investing in AI companies. So because people think AI is somehow a bit overhyped. So firstly, do you think it is a capital winter now? Secondly, as a VC investor yourself, what kind of AI startups would you be interested in investing in the future?
Okay, very good question. I do think there are some overvaluation in the AI space, but I also think AI has a lot of promise. So I think it's really case by case. I think the opportunities for now are that we should, when we invest in pure tech companies, we want to make sure their technology is 18 months ahead of others and can't easily be caught up. Those are the kind of tech companies we would invest in. And we would tend to invest in more advanced things. For example, an AI chip that would do training much faster than before, or an autonomous vehicle that could do certain things that other companies cannot do, or a special type of a robotic arm that can pick up things that others cannot. So these are the kind of differentiated tech investments we like to make. They'll tend to be in wave 4 and maybe wave 3, and they'll tend to have higher barriers, such as semiconductors. These are kind of the pure AI investments. But at the same time, we probably make a lot more investments in AI infusion and AI product cases. For example, companies that might be building an education product with a virtual teacher teaching the first lesson, then as a way for user acquisition, and then for people-to-people tutoring after that. So that would be an example of AI in education. Or we have one of the most proudest investments we incubated and invested in is a company called AI Innovation. And what they build is AI, computer vision, and deep learning as applied to manufacturing. So visual inspections and also in retail and insurance areas. So I think more of our investments, if you look at all the AI related investments, probably 80 to 85% are in AI plus some industry. And they're either building products or infusing something for that industry, or maybe they're an industry player that uses AI to do things better than before. That's 80 to 85%. Probably 15 to 20% are pure tech companies. And in those cases, they have to really be ahead of others by 18 months. And I would say it's harder to do that now compared to 3 or 4 years ago, because there are many, many more people practicing AI. One final problem I would point out is a lot of people have a dream that they want to build a platform, because the most successful companies today, whether you're talking about Google, Facebook, or Amazon, these are all platforms. Or if you talk about B2B companies, Salesforce and companies like that, they're platforms. Zoom is a platform. So people want to build platforms, but we haven't yet figured out how to build an AI platform. And that's because AI is a bunch of modules you integrate into other tools and platforms. It's not a platform in and by itself. So whoever cracks that, I think will have a huge opportunity. But today, a lot of people claim to have platforms, but really they have modules. And to the extent AI doesn't ever have a platform, which might be the case, AI will still create that 15, 16 trillion dollars of value to the economy, but there might not be a Google-like company in the AI space. But instead, AI will just be dispersed in the Google, Amazon, as well as some of the banks and insurance companies and car companies and so on.
Great, thanks. Let's take one question from the audience. Let's see. Do you think AI will automate programming? So there will be no further need of software engineers, computer scientists, data scientists, etc.
Certainly not, but it will automate some programming. The easiest way to think about this is for every job and every task, there are components of that job and task that are routine. And there are components of that job that are complex or strategic or creative. That in the future, people who are engaged in the creative, strategic, and complex aspects, they will keep their jobs. People who do purely routine work, so let's say someone who's just more or less copying and pasting from open source and not writing much original code, well, that job will certainly be gone. People who do manual testing, that job will most likely be gone. So, and it's quite equivalent to many other areas, right? I mean, AI will be decent entry-level journalists, but for a complex article that requires a deep understanding of human nature and having a chance to interview someone, well, AI can't do that. But a financial report or a sports game, AI can do that. And you can extrapolate that probably to almost every job, lawyer, accountant, and so on. I think the really entry-level, routine, repetitive ones are the ones who are going to get replaced. And the people who become really good in what they do and really senior, really good, or the people who are running the robotic solutions, there will always be jobs left. So I think for every job, this is true. But I would say that one thing that differentiates the engineers is that there's a huge shortage of AI engineers today. And also, if you think about the food chain, who's going to control all of those? So if AI is going to replace a bunch of routine jobs, well, who's going to control them? Who's going to manage them? Who's going to program them? It's going to be the engineers. So for those of you who've chosen AI as a profession, you don't have to worry too much.
Right. So AI researchers and engineers cannot be replaced yet.
Right.
Okay. So next question is about COVID-19. Can you comment on the role of AI in the recently discovered COVID-19 vaccines? How can AI be used to speed up the discovery of more effective vaccines?
Yeah, I'm not sure AI is used all that much in the existing vaccines. There are some people using AI to quickly generate possible possible treatments. I'm not sure they were used or not, and I think the pandemic kind of caught us by surprise. So a lot of people working on AI worked on many applications, but no one thought about applying it to pandemic and vaccines. So when the pandemic hits, we didn't have any practice. We didn't have any data. Pandemics are very rare. The last big one was in the 1918. Then there were a few medium-sized ones, but the last sizable one was that long ago. So we don't have the kind of data. So I think the vaccine and treatment use of AI has been limited. Where AI has been used related to the pandemic are things like contact tracing, using robotics for social distancing. And also, I think the fact that our work, life, entertainment, and education have gone online and digital, it creates streams of data that I think in the future will facilitate AI to use. So I think the pandemic has had an unintended consequence of digitizing the world faster, and that will be helpful for AI. But I wouldn't say that AI has done a great job in helping us to find the solutions in healthcare at this point. But hopefully next time we will.
Yeah, I totally agree. So you mentioned AlphaFold during your presentation. Do you think similar techniques could be used for the discovery of vaccines as well?
It would seem intuitive and sensible for that to happen. Yeah, so I think one could speculate that one would potentially extend that. I'm not an expert in vaccines, but it would seem that's an possible extension.
Sure. Okay. Next one. Given the tremendous rise of AI in China, what do you think some of the resource-constrained countries can learn from the experience of the Chinese companies? Moreover, he would like to know how much there should be an emphasis on AI-based research and AI-based engineering when you are a bit resource-constrained.
Well, so for a resource-constrained country, I think it's still critical to always identify your most gifted and talented students and find a way so that they can get advanced training, whether it's in biology or AI or some other advanced area. Because the moment you don't do that, I think you will fall behind. Uh, every country has a small number of really smart people, and I think it's the responsibility of the people in that country to make sure that these great minds are not being wasted. So that would be the first thing. The other one would be to focus on applications of AI. That's a lot easier than AI research. And the third is look at AI applications in areas that only you can do, right? It's one could imagine it's very hard. Let's say you're a small resource constrained country. It's very hard to imagine you would actually build an Amazon that would your local Amazon to beat the U.S. Amazon. Um, or Google or Facebook because they're so powerful and much of what they have is digital. But there are things that are rightfully yours. Um, I think let's take food delivery or use of AI in healthcare, and let's say your main industry is tourism or agriculture or arts and crafts. There are different ways in which AI can fit within your local infrastructure, whether to reduce the cost or to improve the product experience. So focus on things that are local, focus on things that multinationals can't easily do, and also think about what areas you have a lot of data, because it's all because if you have specific areas where you have a lot of data that multinationals do not have, then you have a big advantage over them.
Okay. Thanks. Let's see. I think most of the audience are now based in the UAE, right? So your presentation and your book, AI Superpowers, are mainly about China and the US. So what would be your suggestions to make the UAE an AI superpower by 2031, so in about 10 years?
Yeah, I believe the homogeneity of the Arabic culture, language, religion makes it a very unique makes it a unique market to target. One of the reasons China emerged successfully out of the 15 years ago, it was really U.S. dominated, and China was effectively a technological colony of U.S. like every country was at the time. But the reason China emerged was China was large enough, enough people, and also the Chinese language and culture was different enough, and that the American products were not really serving the Chinese people all that well. Of course, it's very typical for any product to not service other country very well, especially if they're either very small or very poor. And when that happens, if you're very small and very poor, I think you're stuck because what can you do? You can't have a local ecosystem to fight a Google or a Facebook. But if you're small and you have a lot of resources like UAE, I think the opportunity is you can have an entrepreneurial ecosystem. You can build local solutions. And even though UAE is small in population, the Arabic speaking world is sizable. And I think it's similar, somewhat similar to China in the sense that the American products don't currently serve the Arabic speaking population all that well. The search engines from my friends who speak Arabic tell me it's not nearly as good as the English search engine. And I would imagine the same is true for other products also. I doubt Facebook properly addresses all of the religious culture and other components of the country, of the Arabic speaking countries. So I would think it's similar to China in the sense that it's large enough population, is different enough from the US population. Um, the users are not very happy with the American products, so that maybe you can build them. And UAE being a country with significant resources, as well as more and more talent, such as this university, and the ambition to service the Arabic world, I think that would be the biggest thing I would think about going after, because a lot of the things I talk about, they are not proven models. One thing there is a proven model is build great mobile apps, and the mobile apps will get you the data. Then the data will give you a competitive edge. So that's the easiest playbook. And given that there are many people in the Arabic world who are not well served by the American products today, it seems like that's the lowest hanging fruit that both UAE as a country and the entrepreneurs and the companies in UAE can think about.
Yeah. So you think the Arabic language is like unique thing we
Yeah,
should consider in the UAE. So do you
right.
think it would make sense to sort of like make a similar kind of like GPT-3 or so Arabic version of GPT-3 here in the UAE?
Yes, absolutely. Um, that's the cutting edge. Even though I think GPT-3 is still a long ways from commercial use because it's surprisingly good very often, but quite bad sometimes as well, and very hard to predict when it's good or bad. So the commercial applications are not clear yet. Also very expensive to train, but you have the resources. I think you should absolutely train up GPT-3, use it as a basis, maybe teach it at the university, give top researchers in the country access to that, and maybe some new app will come out. Because earlier I was talking more about existing apps like search and social, but maybe GPT-3 will enable something that couldn't be done before. And if you're one of the few countries that can have enough compute power to give researchers access. One limitation though is I don't know how much total Arabic language data there is. And if there isn't enough data, then the power isn't going to be obvious.
Yeah, I think data shouldn't be a problem. We have, I think, tremendous data available.
Okay.
Okay, I think let's do just one last question. So I think it's almost 11 o'clock, 11 p.m. In China now. So you talked about system one and system two cognition. So how far are we in developing mature system two cognition AI? Also, compared to existing mainstream deep learning approaches to AI, what paradigm shifts it would take to obtain high performance system two cognition AI?
Yeah, we know so little about system two. We all just know we want to get there. So we really don't know how to get there. I think there are people who argue forcefully that deep learning is not limited to simple networks and simple classification and can be extended with all kinds of clever ways. There are also people who argue convincingly that classical technologies or even new technologies are needed to be combined with deep learning. There was a very fascinating debate between Jan LeCun and Gary Marcus, and you can find it online to see. But unfortunately, it's a very academic debate. So people religiously believe in one way or the other, but really without enough evidence to either demonstrate their way is right or the other way is wrong. So I think the best thing to do is let both schools move forward. That's the spirit of that we should have for research anyway. Let all 100 flowers bloom and see which one actually bears fruit. In terms of uh, how would I envision progress in system two? I think it's too much to say system two completely equals AGI, because then it might be 100 years, it might be 50 years, we might never see it. But there are some tasks that require skills beyond system one, maybe not quite as system two. My favorite one is probably autonomous driving. This is total L4, L5 level autonomous driving, because for those of you who work on the area, it's clearly not just take a deep neural networks and take over the steering wheel. There's so much interaction, understanding, scenes and inferences and implications, and how to avoid danger, how to read other drivers' minds, how to determine if a pedestrian is crossing the road or not. So it is, in fact, much more complex than just muscle reaction or perception. So I think autonomous driving and other tasks like it, building a robot that serves you dinner. I think tasks like that that are inherently complex and require some degree of multi-domain planning, thinking, conversation, clarification, but is not general intelligence. So I think we should define a number of problems that are much more complex than face recognition, speech recognition, machine translation, but not, but much easier than AGI. So the examples I gave, I think, are some very suitable grand challenges that I think funding agencies and companies and governments can push researchers to do. Because purely doing research wanting to achieve AGI is a very thankless job. You could be working 50 years with nothing to show for it. I think it's much better, even in research, to set a tough goal. We all believe autonomous vehicles should be possible. A smart robot that serves you dinner should be possible. Some people would be optimistic and say 5 years. Others would be pessimistic and say 25. But somewhere between 5 and 25 is the time we should set a grand challenge and see if we can get there. When I went to grad school back in the 80s, speech recognition was viewed as a grand challenge. And after that, machine translation, uh, conversational chatbots. These were all grand challenges once upon a time, but decades later, we've solved them. And it was uh, really thanks to the funding agencies who had the grand vision to set problems that are very tough, but not too tough, as goals for us to go after. So I think now the time has come for us to find those sets of goals that are 5 to 25 years out, use them as milestones towards AGI or towards System 2, but not too far out that you can see results within a PhD thesis. I think countries and companies should be thinking in that direction.
Yeah. Dr. Lee, thank you so much for this inspiring talk and the interesting discussions. And I would also like to thank everyone for attending this session. I look forward to seeing you again next time. So there will be a survey popping up. Please try to complete it at the end. Thank you. Bye-bye.
Okay. Thank you. Bye-bye. Thanks.